Let's start looking at some simple collectives. Initially, we consider, as the first one, we consider the MPI reduce. So what is a reduction? Every process has data, and you combine it together on the root process by performing an operation on it, say max, min, or, product, sum. So every process has data. The data is in a send buffer, so some amount of memory that you've created somehow. The root process is a receive buffer, but because everyone calls the same MPI routine, even if you're not the root, you have to specify a receive buffer. Okay, you can give a null pointer in that case. You need a count, so how many items is everyone sending? So say everyone has one integer or two real numbers, 5 characters. There is a data type. Then there is the operation that you perform on it. You specify what the root process is, and of course everyone has to specify the same root. And then there is the communicator, MPI COM world, unless you know otherwise. So remember that what I give you here is a prototype. So void star means it's the address of some memory. We don't actually write void star in your program. Yes, so about those buffers. If you're working with C, so your send buffer and your receive buffer are void star pointers. So it's an address. So if you're doing a reduction on a scalar variable, you have to write %x, or for cleanliness, void star %x. If x is an array, then it's really already a memory address, and so you can just say x, or you can cast it to void star. Fortran, everything is passed as an address, and so if you do a reduction on a scalar, x, you write x. If you do a reduction on an array, x, you write x. Python, that's the complicated case. So for every MPI routine, there are 2 variants in Python. One can send complete Python objects, and they have names that start with a lowercase letter. This uses the Python pickle module, which is very clever, very versatile, also very slow. If you have a routine that starts with an uppercase letter, then it uses NumPy objects. And so your send and your receive buffer are NumPy objects that have to be created first. This version of MPI in Python is just a small wrapper around the C code, and so it's very efficient. Unfortunately, it doesn't look terribly Pythonic. Okay, take a look at your MPI reduce routine and do exercise 8. Write a program where each process computes a random number, and then process 0 finds the maximum value. For convenience, just let every process print its value to the screen, and you just look at the results to make sure that you indeed find the maximum. Random numbers are a bit tricky, so here is some code on how to generate random numbers in C and in Fortran. Okay, exercise